Hello everyone, and welcome to this demo of Miraculous, a system for semantic dataset discovery. In many conventional approaches, methods rely on syntactical matching rather than on the deeper semantics. When handling a large corpus of datasets, it becomes increasingly challenging to retrieve the true meaning hidden within the table content. Today, I will show how Miraculous focuses on exploring and matching the deep content of datasets with the user input, letting you decide its effectiveness. Let's go first to the search dataset page. Within the first scenario, we are going to use a keyword query that's solar energy innovations. As you can see here, we will get different results as cards. Each one of them is a table within its content, like the breakthrough on photovoltaic cells with the matching semantics of 0.97, and also other table as an advanced photovoltaic materials with a nanotech solar coatings. Now let's take the same exact keyword query and go to the approximate neighbors nearest neighbors. As we can see, the approximate nearest neighbors got a different tables with a different scores, like the solar panel manufacturing and the solar tech incorporation. And also, the second one is the wind turbine projects with offshore wind initiatives. For the solar energy innovation scenario, the cluster target search focuses on extracting and matching very specific context-rich details. For example, the breakthroughs in photovoltaic cells and in nanotech coatings. The higher similarity scores indicates the deep semantic matching. In contrast, the approximate nearest neighbors returns relevant items, but with slightly lower scores and a broader focus. Includes a general manufacturing and event highlights. Let's go back again to the cluster target search and choose another keyword query like the wind energy optimization. So for the wind energy optimization, the cluster target search retrieves results that directly address specific technical improvements, such as the aerodynamic enhancements and turbine performance, resulting in a higher precision scores. Now, if you take the same exact keyword query and navigate to the approximate nearest neighbors to see the results that we get, we can see that the approximate nearest neighbors, while still relevant, produces a broader range of topics, including manufacturing and marketing forecasts, and lower scores, which suggest a more approximate matching. Now the question relies like why CTS is more efficient than the approximate nearest neighbors. We can say, according to the scenarios, the performance of in-depth analysis of a table content, focusing on semantic details that truly match the user intent. And also, because of the approximate neighbors is still fast and scalable, it tends to yield on the broader results that might include related topics but are not as narrowly focused. Now, after discovering a datasets, adding new data is seamless. With Miraculous, you can register a new datasets by simply providing the necessary details. The system then processes the datasets. That is an option that Miracles offers actually. So for each new dataset that is entered, you can navigate through the dataset catalog page, and then within the green background cells, you can process this dataset. That meaning this dataset is going to be digested within the Miraculous pipeline. And this scenario, it makes it really visible for search and the future scenarios. Well, this demonstration is shown for two different search methods, and additionally, the dataset registration and centralized catalog keep the data up to date for ongoing discoveries. Thank you so much for hearing.